So I'll go ahead and introduce Noah's talk here. He'll be talking about Artemis field geology investigations, lessons learned from Apollo, and other co-authors are himself and Schmidt. So go ahead, Noah.
Okay, thanks so much, Shri. And David touched on many of the points that I wanted to make. So this is going to reinforce most of what he said. So hang tight. But I wanted to use this opportunity here at Surrey Forum to talk a little bit about what worked in Apollo and what's going to be done, I think, differently going forward in Artemis. Although I got to be very honest, I can only speak for myself. There have been a number of recent presentations given in the last pandemic months on the status of the training program. Back in April, Cindy Evans gave a talk. There's a YouTube link, and you can see the QR codes for that on the current status of the training program. And then more recently, just a few weeks ago, Kelsey Young and co-authors gave a presentation on training at the workshop on terrestrial analogs for planetary exploration. So I will not speak directly to what's been presented there, but I highly suggest everybody go and watch those presentations. What I'd like to do, though, is talk a little bit about Apollo and really leverage a paper that Jack and co-authors published back in 2011, the GSA special issue. Those special issues become the most important job that interlibrary loan librarians go after. If you haven't read this paper, definitely go and track it down, because it really presents a nice overview of what happened in Apollo, and from training to site selection. I'm going to focus on the training component, and really some of the three big takeaways, particularly relevant to training, are what happened to get astronauts into the field, get astronauts exposed to scientists, and get a crew, a team working together. And there's a quote in the paper that I think is really important, is that field training was to reduce risk to crews and increase crew and ground team productivity. I think we've all learned over the last year and a half now how difficult it is for teams to work together if you're not together. And so when you do these training simulations, when you're together in the field, you develop a camaraderie, a level of communications, and the ability to work together. On the right-hand side is archival footage of the one field training session the Apollo 11 crew took in West Texas in February of 1969, showing what they were doing to begin to work together as a team in a geologic environment. That wasn't, of course, the only time that both astronauts had been in the field getting exposed to geology, but in terms of an actual simulation, that one experience was it. So first, let's start with classroom training, and as David pointed out, classroom training is going to be very important. For Apollo, it was teaching people geology. The textbooks that the crews or the classes were given were these wonderful art relics of the early era of geology, principles of geology, which talked in dismissive terms of the philosophy and theory of plate tectonics. You can imagine now crews that are being trained and classes that are being exposed to geology in classroom settings are not only benefiting from the 50 years of science and lessons learned from Apollo, but also the explosion of understanding of how planets work in the context of the moon in relation to the Earth and other solar system bodies. These classroom trainings set the stage for the quote, show and tell style geologic expeditions that the astronaut classes would have taken. These covered everything from geologic processes, fundamentals, the impact cratering lesson that Gene Shoemaker is giving in this March 1967 film clip, to the nitty-gritty details of mineralogy and petrology. And as David pointed out, these lessons are described in some detail in the reports described at the bottom of my slide. This set up the stage for field training, for taking astronauts and putting them in geologic environments, of exposing them to the lingo, the tools, the expertise, how we go about conducting field work in a geologic environment. This level of training, this exposure, was sort of the stage for Apollos 11 and 12, and by Apollo 13 had developed a much more robust, mature field training investigation. And Finney describes here a little bit of kind of the premise behind what they were going after in this particular investigation in 1964 to Big Bend. And you'll see actually some faces in the video that become familiar. Bill Mulberger there talking the geology with Scott Carpenter and a shirtless Pete Conrad. And that part also becomes important because you're not only exposing them to scientists, to the field sites, you're exposing the astronauts to the scientists, to their peers, people that will help them walk around on the surface of the moon. The video clip at right shows Dale Jackson, that sort of unheralded hero of the Apollo geology program, talking with Dave Scott, Michael Collins, and Roger Chaffee just outside of Flagstaff, Arizona. And as Jack pointed out in that 2011 paper, it was important for the astronauts to get exposed to the scientists and in some cases develop a mentorship-mentee relationship with these geologists, people that they could trust in confidence to talk through the concerns, questions, issues that they may be having. And so not only is it important for crew to build a comfort level with the geology, but also comfort level with the scientists that they'll be working hand in glove with during their expedition to the moon. And so it's important that we also consider that, you know, the astronauts are learning. And so this learning process has to happen also in somewhat informal ways through discussions of, you know, well, why did you pick up this sample when we asked you to collect representative samples? What led you walking through the thought process of what the crew is doing when they're in these field expeditions? As I mentioned before, you know, there was a significant change around the Apollo 13 training for how we approach, how they approached the simulation-based training. And you can see even in Apollo 17, the use of a simulated lunar lander. Of course, there's also simulated rovers that they used. Part of this training included the entire crew, and most importantly were the Capcoms, the people that they were going to be talking to in Houston. And again, part of this building a relationship, a rapport, and a cadence, understanding when to interrupt, when to interject, and how to basically work together, even if you're remote, something that we've all come far too accustomed to. The field sites that were selected for these training exercises reflected the analogs for parts of what the crew would be exposed to. So in the case of Apollo 17, landslide deposits or volcanic deposits. And as David correctly pointed out, of course, impact craters of varying degradation states. Oh, I would also like to point out that in this field campaign, this particular training exercise of Apollo 17, President Nixon's science advisor was there, and these become, I don't want to call it not PR opportunities, but opportunities to bring in people to learn more about what the program is about. Lastly, the Artemis training program, and as was highlighted in actually in Kelsey Young's presentation earlier this month or last month, the three phases of training go from classroom and preliminary field expeditions to really the hardcore training for specific missions, especially once condition landing site is selected. We also have to consider what conditions to recreate. No one location on the Earth will perfectly summarize and synthesize what they'll be exposed to on the moon. I believe exposing the crew to what the extreme illumination conditions of the South Pole of the moon will be very important just for understanding how to work in this incredibly dynamic environment. And so I've brainstormed a few other places there or types of environments, but certainly we can spend hours and hours discussing more down the line. Thank you.